Good morning all. In continuation to our previous discussion on image enhancement, in this discussion we will discuss linear transformation based image enhancement technique. In linear transformation based image enhancement technique, we have to learn two methods. These are image identity and image negative. The mathematical equation of image identity, it is S equals to R, and the mathematical equation of image negative, it is S equals to L minus 1 minus R. So both of these methods we will discuss and we will plot their transformation curve also. So in order to plot the transformation curve, we will use 8-bit image. For 8-bit image, that is for n equals to 8, value of L equals to 2 to the power n, that is equals to 2 to the power 8, it is equals to 256. That is for n equals to 8, number of bit equals to 8, number of gray label is 256, and this 256 gray label, their representation, it start from the gray label 0 and the maximum gray label, it is 255. So let's start with image identity. The general equation of image identity, it is S equals to R, where R is my input intensity level and S is my output intensity level. And in order to plot the curve, we will use the 8-bit image. Along x-axis, we will take R. Along y-axis, we will take our output intensity level S. 4 critical points we will use. First, the origin, that is the gray level 0. Next, we will choose the critical point as L by 4. Next one, it is L by 2. Next critical point, it is 3L by 4. And lastly, it is L minus 1. So earlier we have already discussed if n equals to 8, value of L equals to 2 to the power 8, that is 256. Now if L equals to 256, L by 4, it is 64. L by 2, it is 128. 3L by 4, it is 192. And L minus 1, it is 255. Similarly, along y-axis, we will take the critical point. This is L by 4. This is L by 2. This is 3L by 4. And this is L minus 1. So if L is equals to 256, L by 4, it is 64. L by 2, it is 128. 3L by 4, it is 192. And L minus 1, it is 255. Now here we will make a small table. This side we will write the input intensity level R, and this side we will write the output intensity level S. So S equals to R, the mathematical equation of image identity, it is S equals to R. So if R equals to 0, S is also equals to 0. If R equals to 64, S is also equals to 64. If R equals to 128, S is also equals to 128. If R equals to 192, S is also equals to 192. And if R equals to 255, S is also equals to 255. Now we will plot this transformation curve. When R equals to 0, S equals to 0, representing this point. When R equals to 64, S equals to 64, representing this point. Similarly, when R equals to 128, S equals to 128, representing this point. representing this point. Similarly, when r equals to 192, s equals to 192, this is r equals to 192, s equals to 192. Representing this point. And finally, when r equals to 255, s equals to 255, let us mark this point also. Representing this point. If you connect all these points, this line, it represents the transformation curve of image identity, and the transformation equation for this image identity line, that is for an 8-bit image, it is s equals to r. Now in image identity, the general expression of image identity, it is s equals to r, and in book the transformation curve for image identity, it is represented by this straight line which we have just plotted. In order to understand the image identity, I have made this small project in MATLAB. This is my input image A and this is its histogram. So on this input image A, if I perform the image identity, that is output equals to input. So my output image, so I have obtained an output image which is similar to that of my input image, and the output histogram pattern, it is similar to that of the input histogram pattern of input image A. Image identity operation we generally perform in digital image processing in order to store our original input, in order to store our original image in temporary variables. Next we will discuss image negative. The mathematical equation of image negative, it is s equals to l minus 1 minus r. Again we will take the 8-bit image, that is n equals to 8. If n equals to 8, l equals to 2 to the power 8, that is equals to 256. So if l equals to 256, the equation of s, which is l minus 1 minus r, in place of l we will substitute 256. The equation becomes 256 minus 1 minus r, that is equals to 255 minus r. Now similar to the previous, along x-axis we will take the input intensity level r, along y-axis we will take the output intensity level s. We will take the critical point 0, l by 4, l by 2, 3 l by 4 and l minus 1. If l equals to 256, l by 4 it is 64, l by 2 it is 128, 3l by 4 it is 192 and l minus 1 it is 255. Similarly, we will mark along y-axis. This critical point it is l by 4, this critical point it is l by 2, this one is 3l by 4 and this point it is l minus 1. That is this point l by 4, if l equals to 256, l by 4 it is 64, l by 2 it is 128, 3l by 4 it is 192 and l minus 1 it is 255. Next we will draw a small table. This side we will write input intensity level R and this side we will write the output intensity level S. So R, we will take the critical point 0, L by 4 that is 64, L by 2 that is 128, 3L by 4 that is 192 and L minus 1 that is 255. Now we will determine the value of S for each value of R using this mathematical equation 255 minus R. So if R equals to 0 in this equation, if you substitute R equals to 0, S equals to 255. For R equals to 64 in this equation, if you substitute R equals to 64, S becomes 255 minus 64, that is 191. Similarly, for R equals to 128, S equals to, in this equation, in place of R, substitute R equals to 128. So this equation becomes 255 minus 128. It is equals to 127. For R equals to 192, value of S becomes 255 minus 192, that is equals to 63. And when R equals to 255, in this equation, in place of R, substitute 255. So the value of S becomes 255 minus 255, that is equals to 0. Next, we will plot this transformation curve. When R equals to 0, S equals to 255. When R equals to 0, S equals to 255, representing this point. When R equals to 64, S equals to 191. When R equals to 64, S equals to 191, tentatively representing this point. When R equals to 128, S equals to 127. When R equals to 128, S equals to 127, tentatively representing this point. Now when R equals to 192, S equals to 63. Let me mark this point. When R equals to 192, S equals to 63, representing this point. And when R equals to 255, S equals to 0. When R equals to 255, S equals to 0, representing this point. Now if you connect all these points, this transformation curve, it represents the transformation curve of image negative, and the mathematical equation of image negative for this transformation curve, that is for this 8-bit image, it is S equals to 255 minus R. So in image negative, the general equation of image negative, S equals to L minus 1 minus R, and in book the transformation curve for image negative is represented by this straight line which we have plotted just now. In order to understand the image negative, this is a small project work I made it in MATLAB. This is my original input A and this is its histogram. On this input image A, I have performed image negative operation, and as a result I obtained this as my output image B, and this is its corresponding histogram. So in input image A, consider this object. In original image A, this object, it is of black color, and after performing the image negative operation, this black color becomes white color in my output image B. Similarly, you can observe this object. This object in the original image, it is of white color, it is of bright color, and after performing the image negative operation, this object in the output image, it becomes black color, it becomes dark color. Similar trends you can observe in histogram also. In histogram of original image A, this peak, it corresponds to the dark side, and after performing the image negative operation, that particular peak, it is shifted in the bright side. Similarly, look at this valley region in the original histogram plot of image A. This valley region, it is in the bright side in the histogram plot of image A. After performing the image negative operation, that particular valley, it is shifted in the dark side. So in this discussion, we have discussed the linear transformation based image enhancement technique such as image identity and image negative. In our next video, in our next lecture, we will solve some numerical question based on image identity and image negative. So today I am going to stop here. If you have any suggestion, if you have any doubt, you can write it in the comment section or you can write email to me. Till then, happy learning, have a good day and thank you all.